အားလုံးပဲမင်္ဂလာပါဒီနေ့ကလည်းဆိုဒီ Cam Academy မှာရှိတယ်ပေါ့နော် linear algebra ကိုပြန်နွေးနေကြတာပေါ့နော်အဲ့လိုဆိုဒီနေ့က matrix ထိရောက်နေပြီဆိုတော့ဒီဟာလေးကိုဆက်ပြီးလေ့လာကြရအောင်လို့နော်
I have here 3 equations of 4 unknowns, and you can already guess, or you already know, that if you have more unknowns than equations, you're probably not constraining it enough. So you're actually going to have an infinite number of solutions, but those infinite number of solutions could still be constrained within, well, let's say that let's say we're in 4 dimensions in this case, because we have 4 variables. Maybe we're constrained into a plane in 4 dimensions, or if we're in 3 dimensions, maybe we're constrained to a line. A line is an infinite number of solutions, but it's kind of a more constrained set. So let's solve this set of linear equations, and we've done this by elimination in the past. But what I want to do is I want to introduce the idea of matrices, and the matrices are really just arrays of numbers that are shorthand for this system of equations. So let me create a matrix here. So I could just create a coefficient matrix, where the coefficient matrix would just be, let me write it neatly, the coefficient matrix would just be the coefficients on the left-hand side of these linear equations. So the coefficient there is 1, coefficient there is 1, coefficient there is 2. You have 2, 2, 4, 2, 2, 4, 1, 2, 0, 1, 2. There's no coefficient on the x3 term here because there's no x3 term there. So we'll say the coefficient on the x3 term there is 0. And then we have 1, minus 1, 1, minus 1, and 6. Now if I just did this right there, that would be the coefficient matrix for this system of equations right there. But what I want to do is I want to augment it. I want to augment it with what these equations need to be equal to. So let me augment it. And what I'm going to do is I'm going to draw a little line here and write the 7, the 12, and the 4. And I think you can see that whatever this right here is just another way of writing this. And just by the position, we know that these are the coefficients on the x1 terms. We know that these are the coefficients on the x2 terms. And what this does, it really just saves us from having to write x1 and x2 every time. But we can essentially do the same operations on this that we otherwise would have done on that. So what we can do is we can replace any equation with that equation times some scalar multiple plus another equation. We can divide an equation or multiply an equation by a scalar. We can subtract them from each other. We can swap them. So let's do that in an attempt to solve this equation. So the first thing I want to do, just like I've done in the past, is I want to get this equation to the form of where if I can, I have a 1, my kind of leading coefficient in any of my rows is a 1, and then every other entry in that column is a 0. And in the past, I made sure that every other entry below it is a 0. That's what I was doing in some of the previous videos when we tried to figure out if things were linearly independent or not. But now I'm going to make sure that if there's a 1 and if there's a leading 1 in any of my rows, that everything else in that column is a 0. And that, what I'm calling, with that form I'm doing, is called Reduced Row Echelon Form. Let me write that. Reduced Row Echelon Form. And if we call this Augmented Matrix Matrix A, then I want to get it into the Reduced Row Echelon Form of Matrix A. And matrices, the convention is, just like vectors, you make them nice and bold, but use capital letters instead of lowercase letters. We'll talk more about how matrices relate to vectors in the future, but let's just solve this system of equations. So the first thing I want to do is, in an ideal world, I would get all of these guys right here to be 0. So let me replace this guy with that guy with the first entry minus the second entry. So let me do that. So I am just going to, the first row isn't going to change. It's going to be 1, 2, 1, 1, and then I get a 7 right there. That's my first row. Now the second row, I'm going to replace it with the first row minus the second row. So what do I get? 1 minus 1 is 0. 2 minus 2 is 0. 1 minus 2 is minus 1. And then 1 minus minus 1 is 2. Right? That's 1 plus 1. And then 7 minus 12 is minus 5. All right. Now I want to get rid of this row here, or I don't want to get rid of it, I want to get rid of this 2 right here. I want to turn it into a 0. So let's replace this row with this row minus 2 times that row. So what I'm going to do is this row minus 2 times the first row. I'm going to replace this row with that. So 2 minus 2 times 1 is 0. That was the whole point. 4 minus 2 times 2 is 0. 0 minus 2 times 1 is minus 2. 6 minus 2 times 1 is 6 minus 2, which is 4. And then 4 minus 2 times 7 is 4 minus 14, which is minus 10. All right, now what can I do next? Well, ideally, see, I don't have any, well, this guy, you can kind of see this row is kind of, well, we'll talk more about what this row means when all of a sudden it's just all been zeroed out. There's nothing here. If I had a non-zero term here, then I'd want to zero this guy out, although it's already zeroed out. So I'm just going to move over to this row. So the first thing I want to do is I want to make this leading coefficient here a 1. So what I want to do is I'm going to multiply this entire row by minus 1. So if I multiply this entire row times minus 1, in fact, I don't even have to rewrite the matrix. This becomes plus 1, minus 2, plus 5. I think you can accept that. All right, now what can we do? Well, let's turn this right here into a 0. So let me rewrite my augmented matrix in the new form that I have. So I'm going to keep the middle row the same this time. So my middle row is 0, 0, 1, minus 2, and it's augmented, and I get a 5 there. And what I want to do is I want to eliminate this minus 2 here. So why don't I add this row to 2 times that row, right? Then I would have minus 2 plus 2, and that'll work out. So what do I get? I get well, these are just leading zeros. And then I have minus 2 plus 2 times 1. Well, that's just 0. 4 plus 2 times minus 2. 4 plus 2 times minus 2. That's minus 4. So that's 4 plus minus 4. That's 0 as well. And then you have minus 10 plus 2 times 5. Well, that's just minus 10 plus 10, which is 0. So that one just got zeroed out. And what I want to do, and normally when I just did regular elimination, I was happy just, having the situation where I just had these leading ones, everything below it were zeros, but I wasn't too concerned about what was above our ones. But what I want to do is I want to make those into a 0 as well. So I want to make this guy a 0 as well. So what I can do is I can replace this first row with that first row minus the second row. So what is 1 minus 0? That's just 1. 2 minus 0 is 2. 1 minus 1 is 0. 1 minus minus 2 is 3. 7 minus 5 is 2. And there you have it. We have our matrix in reduced row echelon form. This is the reduced row echelon form of our matrix. I'll write it in bold. Of our matrix A right there. And you know it's in reduced row echelon form because all of your leading ones in each row. So what are my leading ones in each row? I have this one and I have that one. They're the only non-zero entry in their columns, and these are called the pivot entries. These are, let me label that for you. That's called a pivot entry. Pivot entry. They're the only non-zero entry in their respective columns. If I have any zeroed out rows, and I do have a zeroed out row, it's right there. So this is zeroed out row. Just the style or just the convention is that for reduced row echelon form, that has to be your last row. So we have the leading entries are the only, there are 1. That's one case. You can't have this a 5. You'd want to divide both. You would want to divide that equation by 5 if this was a 5. So your leading entries in each row are 1. But the leading entry in each successive row is to the right of the leading entry of the row before it. Right? This guy right here is to the right of that guy. This is just the style, the convention of reduced row echelon form. And if you have any zeroed out rows, it's in the last row. And then finally, of course, and I think I've said this multiple times, this is the only non-zero entry in the row. Now what does this do for me? Well, now I can go back from this world back to my linear equations, because we remember that these were the coefficients on x1, these were the coefficients on x2, these were the coefficients on x3, on x4, and then these were my constants out here. So I can rewrite this system of equations using my reduced row echelon form as x1 plus 2x2, there's no x3 there, so plus 3x4 is equal to 2. And then this equation, no x1, no x2, I have an x3. I have x3 minus 2x4 is equal to 5. And then I have no other equation here. This one got completely zeroed out, so I was able to reduce this system of equations to this system of equations. Now, the variables that you associate with your pivot entries, we call these pivot variables. So x1 and x3 are pivot variables. Pivot variables. And then the variables that aren't associated with a pivot entry, we call them free variables. So x2 and x4 are free variables. But now let's solve for, essentially you can only solve for your pivot variables. The free variables we can set to any variable, and I said that in the beginning of this equation. We have fewer equations than unknowns, so this is going to be a not well constrained solution. You're not going to have just one point in R4 that solves this equation. You're going to have multiple points. So let's solve for our pivot variables, because that's all we can solve for. So this equation tells us right here, it tells us x3, let me do it in a good color, x3 is equal to 5 plus 2x4, and then we get x1 is equal to 2 minus x2, 2 minus 2x2, 2 minus 2x2 plus, minus 3x4. Right, I just subtracted these from both sides of the equation. Now this right here is essentially as far as we can go to the solution of this system of equations. I can pick really any values for my free variables. I can pick any values for my x2s and my x4s, and I can solve for an x3. But what I want to do right now is write this in a slightly different form so that we can visualize a little bit better. And of course, it's always hard to visualize things in 4 dimensions. But so we can visualize things a little bit better as to kind of the set of this solution. So let's write it this way. If I were to write it in vector form, our solution is the vector x1, x2, x3, x4, and what is it equal to? What is it equal to? Well, it's equal to, let me write it like this. It's equal to, I'm just essentially rewriting this solution set in vector form. So x1 is equal to 2, let me write a column there, plus x2, let me write it this way, plus x2 times something, plus x4 times something, plus x4 times something. So so x1 is equal to 2 minus 2 times x2, or plus x2 times minus 2. So I put a minus 2 there, and then I can say plus x4 times minus 3. So I can put a minus 3 there. This right here, these first entries of these vectors just literally represent that equation right there. x1 is equal to 2 plus x2 times minus 2 plus x4 times minus 3. Now what does x3 equal? What does x3 equal? x3 is equal to 5, put that 5 right there, plus x4 times 2, plus x4 times 2. x2 doesn't apply to it, so we can just put a 0. 0 times x2 plus 2 times x4. Now what does x2 equal? Well, you could say x2 is equal to 0 plus 1 times x2 plus 0 times x4, right? x2 is just equal to x2. It's a free variable. And similarly, what is x4 equal to? x4 is equal to 0 plus 0 times x2 plus 1 times x4. Now what does this do for us? Well, all of a sudden here, we've expressed our solution set as essentially the linear combination of, of the linear combination of three vectors. This is a vector you could view it as almost a coordinate with either a position vector. It is a vector in R4. You can view it as a position vector or a coordinate in R4. And then you could say, look, our solution set is essentially, this is in R4. Each of these have 4 components, but you can imagine it in R3. But I have my solution set is equal to some vector there that, that's the vector. Think of it as a position vector would be the coordinate 2, 0, 5, 0, which obviously this is 4 dimensions right there. But it's equal to multiples of these 2 vectors. So let's call this vector right here, let's call this vector vector A, and let's call this vector right here vector B. So our solution set is all of this point, which is right there, or I guess we could call it that position vector, right? That position vector will look like that, where you're starting at the origin right there, plus multiples of these 2 guys. So if this is vector A, let's do vector A in a different color. Vector A looks like that. So let's say vector A looks like that, and then vector B looks like that. This is vector B, and this is vector A. And I don't know if this is going to be easier or harder for you to visualize, because obviously we're dealing in 4 dimensions right here, and I'm kind of just drawing it on a 2-dimensional surface. But what you can imagine is that the solution set is equal to this fixed point, this position vector, plus linear combinations of A and B. And we're dealing, of course, in R4. Let me write that down. We're dealing in R4. But linear combinations of A and B are going to create a plane, right? You can just take, you can multiply A times 2 and B times 3, or A times minus 1 and B times minus 100. You can just keep adding and subtracting these linear combinations of A and B, and they're going to construct a plane that contains the position vector, or that contains the point 2, 0, 5, 0. So the solution for these 3 equations with 4 unknowns is a plane in R4. A plane in R4. And I know that's really hard to visualize, and maybe I'll do another one in 3 dimensions. But hopefully this at least gives you a decent understanding of what an augmented matrix is, what reduced row echelon form is, and what are kind of the valid operations I can perform on a matrix without kind of messing up the system.
Okay, ပါဒါလေးကတော်တော်လေးတော့မျက်စိနဲ့ရှင်းသွားမယ်နည်းလို့ဒီ row echelon form ကိုရင်တော့ခေါင်းနဲ့ရှုပ်နေကြပါရောလားမမိလားမသိဘူးမောင်လေးညီမလေးတို့လေဒီဟာလေးနဲ့ပတ်သက်ပြီး question နဲ့မေးကြရှိတာပေါ်လေးရှင်းသွားမယ်ထင်တယ်လဲဆိုတော့ရမ်းရှုပ်တယ်လို့မမြင်ဘူးဒီဟာလေးကကိုယ်တိုင်တွက်ဘူးလေပေါ့နော်သင်္ချာတွက်တာဖြစ်တဲ့အတွက်အရန် trade ထူတော့မရှိဘူးပေါ့မောင်လေးညီမလေးအကုန်လုံးနားလည်မှာပါဒီဟာနဲ့ပတ်သက်ရလဲဆို question မေးကြရှိမေးပါအဲ့လဲနားလဲသူပြန်ရှင်းပေးမယ်ပေါ့နော်ရှင်းကြလားမသိဘူးဒီဟာလေးကိုလေဘယ်လိုခံစားရလဲဒီဟာလေးနဲ့ပတ်သက်ပြီးကြည့်ရောလေဘယ်ဟာလေးရှုပ်နေလဲကိုမျက်စိထဲမှာအရင်တော့အဲ့ဆိုဒီဟာကို question တွေ exercise တွေလုပ်ထားတာဖြစ်တဲ့အတွက်ဒီဟာကြီးအရင်တော့ရှုပ်မယ်လို့လည်းမမြင်ဘူးပေါ့နော်ဘယ်လိုမြင်လဲမသိညီမရင်တို့အဆင်ပြေလားညီမလား
ဟုတ်ပါအဲ့ဒါဆိုနောက်ဆုံးကလေ x1 x2 x3 x4 မှာလေx2 ရဲ့0 0ရဲ့ပြီးတော့1ရဲ့0အဲ့ဒါရှားသွားတဲ့ဟာမျိုးသိနေသိလိုက်
အမှန်ကဒီ1ရဲ့အမှန်ကလေဒီ formula နှစ်ခုတည်းလည်းဒီမှာခုလို့ဆိုရှိတာဟုတ်ဒီ formula တစ်ခုနားလဲ h ကိုဘယ်လို h1 ကိုဘယ်လိုရလဲ h3 ဘယ်လိုရနားလဲဒါပေမဲ့ h2 နဲ့ h3 ကလည်းဆိုဘာမှ information မရှိဘူးဟုတ်တယ်ဟုတ်ခုလောဆယ်လေလောဆယ် तू ကမရှိရ तू h2 နေရာမှာ तू 1ပေးလိုက်တယ် h4 နေရာမှာ तू 1ပေးလိုက်ဒါပဲဒါဘာမှ trade မလုပ်ထားဘူး तू တခြားဟာ तू တခြား तू represent လို့ဆိုတဲ့သဘောလေးပေါ့နော် okay तू က h2 ဖြစ်တဲ့အတွက်နဲ့ h2 မှာတော့1ရှိမယ်ဆိုတဲ့သဘောပေါ့နော် h4 represent လုပ်တာဖြစ်တဲ့အတွက် h4 နေရာမှာ1ရှိမယ်တခြားနေရာမှာ तू information မရှိဘူးလေမရှိလည်းမြင်လာလား A4 ဖြစ်တဲ့အတွက်သူ A4 မှာ1ပေးလိုက်ပေါ့နော်ဒါ better ဖြစ်တဲ့အတွက်ပေါ့နော် A3 မှာဆိုလည်းသူ A3 မှာပဲသူ1ပေးတယ်တန်းနေတယ်ဘာမှမပေးရဘူးဒီဟာတွေသူ့မှာ info အခုအဲ့ဒါဒီ information တစ်ခုပဲရှိရလေဟုတ်တယ်ဟုတ်သူတို့ echelon ပြောင်းလိုက်တော့ဒီမှာရရ reduce လုပ်လိုက်တာဒီတိရောက်သွားပြီဟုတ်တယ်ဟုတ်ဒီတိရောက်မှကြည့်မယ်ဆိုရင် A1 information ရှိနေပြီ A3 information available ရှိနေပြီပေါ့နော်ဒါပေမဲ့ H2 နဲ့ H4 information လည်းဆိုမှမရှိဘူးပေါ့မရှိဘူးဆိုတော့ဘယ်လိုလုပ်လဲဆိုတော့ဟုတ်ပြီဒီနှစ်ခုကိုငါနဲ့ H4 ယူလိုက်တဲ့သဘောနဲ့ H2 လည်း H3 ယူလိုက်တဲ့သဘောနဲ့အပုံစံမျိုးသူလုပ်ထားတယ်ပေါ့နော်အဲ့မှာဆိုရင်ဒီ H2 ဒီမှာနေအကောင့်သူ0ပေးတာဒီမှာဆိုလည်းကြည့်ပါအောင်0ပေးတာပေါ့နော်အဲ့ဒါထားလေးသူလုပ်ထားလေးဆိုသဘောလေးပေါ့ Nên tôi lấy ăn được là đây là tây tây đã tôi intuition mà tây đấy bọn nó tôi ăn được gì lại mà nó tây đấy thì mà chỉ nó đấy tôi bảo là được gì sao nó sẽ như này đấy mà bao giờ gì lại bọn nó là người ta tìm là tây tham mi đã thì ha lâu mà tôi mà chỉ là bây giờ bây giờ đã bây giờ thì tôi ăn là đông chảo à thì bọn nó nhớ bọn nó nhưng đi ha lấy thì là ba bên nhà mà đông này bọn nó machine learning mà xong này đấy là số đi là số này mấy bọn nó better metric đều mà ví dụ machine learning mà dàn đông raเลยဆိုတော့ तू ကတည်တယ်ဒါလည်းဆိုတော့ဒီ number နဲ့ play လုပ်နေရတာပေါ့နော် machine learning မှာ training လုပ်ရင် number နဲ့ပဲသွားတာလေဆိုတော့ transformation တွေဘယ်လိုလုပ်မလဲ image ဆိုရင် image ကို number ပြောင်းပြီး transform ဘယ်လိုလုပ်မလဲကိုလိုချင်းပုံစံမျိုးတွေဘယ်လို cut လိမ့်မလဲအဲ့လိုမျိုးတွေဆိုရင်ဒါဒီဟာတွေကိုလုပ်သွားရတယ်ပေါ့နော် shape လိုက်တယ်ဒါကဒီမှာဆို space ကိုဟို shape to shape လုပ်တဲ့ပုံစံမျိုးတွေဖြစ်တဲ့အတွက်ပေါ့နော်ဒီဟာလည်းအရင်ရေးပါတယ်ပေါ့ vector တို့ matrix တွေကလေဟုတ်ပါပြီအရင်ကောင်းတဲ့ question ကဒီဟာပြုံးနေကြည့်လိုက်တာလေပြုံးနေမြစ်တွေကြောင်သွားလိုက်မယ်သိရမလားဘာကြောင့် 1 တော့ထည့်ရတယ်ပေါ့ဘာမှလည်း 1 ထည့်တာဘာမှလည်းမရှိပဲနဲ့ပြုံးနေဘာလို့ 1 ထည့်ရတယ်ဆိုတဲ့ဟာတွေကလည်းစိတ်ချုပ်စေတယ်ပေါ့နော်အဲ့ဒါဆိုခုနကအဲ့ဒါလေးတစ်ချက်သတိထားလိုက်တယ်ဆိုတော့လက်စခုနကညီမလေးရင်တူလို့ပဲလက်စနည်းနည်းကြောင်သွားတယ်ကျွန်တော်သူ့ဒါကိုပြောချင်တာဆိုပြန်ပြီးသိချာလေးဖြစ်သွားတယ်ပေါ့နော်ကဲပါကျေးဇူးတင်ပါတယ်ဒါလို့ရော question တွေရှိပါတယ်ခင်ဗျာ
အဲ့ဒါအပေါ်ကလက္ခဏာဘယ်လိုပြောင်းသွား
ဘယ်လက္ခဏာလဲ
ဒီရားရဲ့ဒုတိယမြောက်အကွက်က
ဘယ်ဟာလဲသူဒီလက္ခဏာလေးလဲသူတက်မိုင်းနဲ့ဝင်လိုက်မြောက်လိုက်လေမောင်လေးရဲ့
ဟော
ဒီမှာလေဒီမှာမိုင်းနဲ့လေးရှိတယ်မလားအဲ့ဒါဆိုဒီမှာစမိုင်းနဲ့ဘယ်လိုရှိတယ်မလားဒရိုလို့မိုင်းနဲ့ဝင်လိုက်မြောက်လိုက်တာ0မိုင်းနဲ့ဝင်လိုက်မြောက်တော့0မိုင်းနဲ့ဝင်လိုက်မြောက်တော့0မိုင်းနဲ့1မိုင်းနဲ့ဝင်လိုက်မြောက်တော့1ဟုတ်တယ်ဟုတ်မိုင်းနဲ့2ကိုဒါအစတော့2ပေါ့နော်2မိုင်းနဲ့1နဲ့မြောက်လိုက်တော့2ဒါအစ5 -5 ရှိရမလား -5 ကိုသူက -1 နဲ့မြောက်လိုက်တော့ -5 ဖြစ်သွားတယ်5ဖြစ်သွားတယ်ပေါ့နော်အဲ့ဒါလေးရှင်းလာတာညီမမောင်လေးဟုတ်ပြီတခြားလို့ရော question တွေရှိပါသလားခင်ဗျာမရှိတဲ့အဆင်ပြေလားမမောင်လေးထွန်းကလည်းအဆင်ပြေလား
ဟိုအောက်ကလေဟို0တွေဖြစ်တဲ့ဟာကိုမသိอ่ะ
အော်0တွေဖြစ်တာအမှန်ဒီလိုလိုက်တာမောင်လေးအမရဲ့သူအမှန်မှန်တော့အဲ့ဒီ0တွေမှဘယ်ထိရောက်ပြီလဲဆိုတော့ okay အဲ့ဒါဒီထိတော့အဆင်ပြေသွားပြီဟုတ်ဒီထိကခုနကဒီထိရောက်ပြီဟုတ်တယ်ဟုတ်အဲ့ဒါဆိုဒီ row နှစ်ခုကို0တွေဖြစ်ချင်တယ်ဟုတ်တယ်ဟုတ်အဲ့ဆိုဘယ်လိုလုပ်လိုက်လဲဆိုတော့ तू ကဒီဟာကိုဒီမှာဒီနှစ်ခုကိုကြည့်မယ်ဆိုတော့ညီမဒီနှစ်ခုရဲ့ relation ဒီနေ့ correlation နဲ့မှမြင်လားမသိဘူးဒီ30က9ရဲ့နှာခေါက်မြောက်30ဟုတ်တယ်ဟုတ်ဒီ4ကလည်းနေ့နှာခေါက်မြောက်ရင်30လေးလေဒီမှာဆိုတော့တိတ်ကလည်း तू ကဒီနှစ်ခုရဲ့သူတို့ linear correlation ကိုကြည့်မယ်ဆိုရင်ဒါ2နဲ့မြောက်လိုက်ရင်အကုန်လုံးထွက်လာမယ့်ဟာရယ်လေ तू က0ဖြစ်ချင်တာဖြစ်တဲ့အတွက်ဒီဟာလေးကို तू ပဲ2နဲ့မြောက်ပြီးဒီကသွားနှုတ်လိုက်တယ်ပေါ့ဒီဟာကိုဒီမှာသွားနှုတ်လိုက်တဲ့ပုံစံမျိုးလေး free 2မဟုတ်ဘူးဒီစိတ်မြင်လားမ
မြင်အဲ့
ဒါမျိုးလေးပေါ့နော်ဟုတ်ပြီနောက် question လေးရှိပါသလားခင်ဗျာဒါကကိုလာဒါတို့ကဒါ linear လေးသူတို့ linear relationship ကိုရှာနေတာပေါ့နော် linear correlation တွေရှာနေတယ်ပေါ့နော်ဒီ information ကိုငါစီလုပ်ချင်တယ်ဒီဟာကိုတွန်းတိုင်ငါဘယ်လိုလုပ်မလဲဒီဟာ information ကမှရှိရဒီဟာကိုငါဘယ်လိုဖြစ်လုပ်ချင်တယ်အဲ့လိုမျိုးပေါ့နော်သူပြောချင်တာ redundant information ကိုအကုန်ထုတ်ပစ်ချင်တယ်ဆိုတဲ့သဘောလေးသိတာမှသူကလေဒီမှာလေတကယ်အရေးပါတဲ့ information ကိုပဲကြံခဲစေချင်တယ်ပေါ့နော်အရေးမပါတဲ့ဟာတွေကိုလောက်ရအဲ့လိုဆိုအဓိက machine learning မှာလုပ်နေတာဘယ်ဟာကိုယ့်ရဲ့ model designing parameter ပါလဲပေါ့နော်သိရမလားလူတယောက်ရဲ့ face ကိုဒီလူကို recognize လုပ်မယ်ဆိုရင်ပေါ့နော်သူ့ရဲ့မျက်လုံးကအရေးကြီးတာလားသူ့ရဲ့ပါးစပ်ကဘယ်ညာလေးတယောက်နဲ့မတူတာလားဘယ်ဟာလေးတွေကတော့ age လေးတွေကမတူကြဘူးဘယ်လိုညာလေးတွေအရေးပါတဲ့ feature လေးတွေပေါ့နော်ဒါပြောမယ်ဆိုရင်ကွာဒီဟာတွေလိုက်ရှာမယ်ဆိုရင်မလိုအပ်တဲ့ information တွေမသုံးချင်ဘူးသဘောပေါ့နော်ဒါဆိုလိုအပ်တယ်တော့က essential ဖြစ်တယ် duplicate information တွေဘာလုပ်မယ်ပေါ့နော်တကယ်လိုအပ်တဲ့ essential ဖြစ်တဲ့ information ကိုဆွဲထုတ်ပြီးတော့မှကွာ training ပေးချင်တဲ့သဘောလေးပေါ့နော်အဲ့လိုသဘောမျိုးလုပ်ချင်လို့သူကလုပ်တဲ့ပုံစံမျိုးလေးနည်းနည်းရှင်းလာတာမသိဘူး machine learning နဲ့ပြန်ပြီးတော့ဆက်ဆက်တဲ့ခါကျရင်လေဒီဟာအဲ့ဒါဆိုဒီဟာကြလုံးဝဒီနောက်မှကျရင်ဒီ dimension reduction တွေပါကျရင်လာမယ်ပေါ့နော်ဒီဟာနဲ့ပတ်သက်ပြီးတော့လေနော်ဒီအဲ့ဒါနောက်တစ်ခုသွားအောင်နော်အားလုံးအဆင်ပြေလားသူကျန်နေလဲအဆင်ပြေဖို့မောင်လေးထွန်းခိုင်လည်းအဆင်ပြေလားမောင်လေးဒီတော့ထားအောင်ခံမခေါ်မိဘူးနော်ထွန်းခိုင်လည်းမှတ်နေ
ပြေပါတယ်ခင်ဗျ
โอเคအဲ့ဒါနောက်တစ်ခုသွားမယ်နော်
Figure it never hurts getting as much practice as possible solving systems of linear equations. So let's solve this one. And what I'm going to do is I'm going to solve it using an augmented matrix, and I'm going to put it in reduced row echelon form. So what's the augmented matrix for this system of equations? 3 unknowns with 3 equations. So it'll be, I'll just have to do the coefficients. So the coefficients of the x terms are just 1, 1, 1. Coefficients of the y terms are 1, 2, and 3. Coefficients of the z terms are 1, 3, and 4. 1, 3, and 4. And let me show that it's augmented. And then they equal 3, 0, 3, 0, and minus 2. Now I want to get this augmented matrix into reduced row echelon form. So the first thing, I have a 1 leading 1 here. That's a pivot entry. Let me make everything else in that column equal to a 0. So so I'm not going to change my first row, so it'll just be a 1, a 1, a 1, my dividing line, and then I have a 3. Now, to make to 0 this out, let me just replace the second row with the first row minus the second row. So 1 minus 1 is 0. 1 minus 2 is 1 minus 2. Actually, a better thing to do, because I eventually want this to be 1 anyway, let me replace this row with the second row minus the first row, instead of the first row minus the second row. I can do it either way. So the second row minus the first row. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. And then 0 minus 3 is minus 3. Now, I want to also zero this out. So let me replace this guy with this equation minus that equation. So 1 minus 1 is 0. 3 minus 1 is 2. 4 minus 1 is 3. Minus 2 minus 3 is minus 5. Fair enough. So I got my pivot entry here. I have another pivot entry here. It's to the right of this one, which is what I want for reduced row echelon form. Now I need to target this entry and that entry. I need to zero them out. So let's do it. So we get, I'm going to keep my second row the same. My second row is 0, 1, 2, and then I have a minus 3, the augmented part of it. And to zero this guy out, what I can do is I can replace the first row with the first row minus the second row. So I get 1 minus 0 is 1. 1 minus 1. There's a bird outside. Let me close my window. So where was I? I'm replacing the first row with the first row minus the second row. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 2 is minus 1. And then 3 minus minus 3. So that's equal to 3 plus 3. So that's equal to 6. Right? 1 minus 0 is 1. 1 minus 1 is 0. Negative 1. And then 3 minus negative 3. That's 6. I always want to make sure I don't make a careless mistake. Now let me get rid of this entry right here. Let me zero that out. So let me replace the third row with the third row minus 2 times the second row. So we have 0 minus, 2 times 0, that's just going to be 0. 2 minus 2 times 1, that's 2 minus 2, that's 0. 3 minus 2 times 2, that's 3 minus 4, or minus 1. And then finally, minus 5 minus 2 times minus 3. Let me write that down. Minus 5 minus 2 times minus 3. It's minus 5 minus 6. That's minus 5 plus 6 is equal to 1. I really wanted to make sure I didn't make a careless mistake there. So that is equal to 1. So I'm almost done, but I'm still not in reduced row echelon form. This has to be a positive 1 in order to get there. It can't be anything other than a 1. That's just the style of reduced row echelon form. And then these guys up here have to be zeroed out. Well, the easy thing to do, let me just multiply this equation by minus 1. So then this becomes a plus 1, and then that becomes a minus 1. And then I just need to zero out these two guys up here. So let's do it. So my equation, I'm going to keep my third row the same. My third row is now 0, 0, 1, minus 1. 0, 0, 1, minus 1. And now I want to zero this guy out. So what I can do is I can set my first row equal to my first row plus my last row, because if these two add up, they're going to be equal to 0. So what do I get? 1 plus 0 is 1. 0 plus 0 is 0. Minus 1 plus 1 is 0. 6 plus minus 1 is 5. Now I want to zero this row out. And to zero this row out, what I can do is I'll replace it with the second row minus 2 times the first row. Right? So 0 minus 2 times 0 is just 0. 1 minus 2 times 0 is just 1. 2 minus 2 times 1 is 0. Minus 3 minus 2 times negative 1. Let me write that down. Minus 3 minus 2 times minus 1. Don't want to make a careless mistake. So what is that equal to? This is equal to minus 3 minus 2, or minus 3 plus 2, which is equal to minus 1. So that's equal to minus 1. And now I have my augmented matrix in reduced row echelon form. Reduced row echelon form. My pivot entries are the only entries in their columns. They're each pivot entry in each successive row is to the right of the pivot entry before it. And actually I have no free variables. Every column has a pivot entry. So let's go back from the augmented matrix world and kind of put back our variables there. So what do we get? We get x plus 0y plus 0z is equal to 5. That's that row right there. We get 0x plus 1y plus 1y plus 0z is equal to minus 1. That's that row right there. And then finally, we have 0x plus 0y plus 1z is equal to minus 1. That's that row right there. And just like that, we've actually solved our system of 3 equations with 3 unknowns. That's the solution right there. I just wrote it in this way just so you see it corresponding, but obviously I could have written them closer to their equal sign. So hopefully you found that vaguely useful.
Okay, ပါဒီဟာလေးကတော့ခုနကနည်းနည်းရှုပ်တဲ့ဟာလို့ပြန်ပြီးတော့ရှင်းသွားတယ်ပေါ့နော်ပို့ပြီးနှာခေါက်လို့တော့နှာခေါက်မှတ်မိတယ်ပေါ့နော်ပို့လေးကိုဘယ်လိုလုပ်လဲကိုမျက်စိနဲ့မြင်သွားတယ်ပေါ့နော်တို့အချွန်လုံးဘယ်လိုပုံစံမျိုးပြောင်းလဲပေါ့နော်ကိုစီမှာ equation 3ခုရှိရင်ပေါ့နော်အဲ့ဒါလေးကိုဘယ်လို equation ပုံမှန်ဆိုလဲဆိုဒီဟာလေး predictive way နဲ့ခြားတာတွေရှိတယ်ပေါ့နော်ဆိုဒီဟာလေးက row အချွန်လုံး form ပြောင်းပြီးတော့ x ရဲ့ value ကဘာလဲ y ရဲ့ value ကဘာလဲ z ရဲ့ value ကဘာလဲဆိုတာရှာလိုက်ဆိုသဘောလေးပေါ့နော်ရန် trade ထူတော့မဟုတ်ဒီဟာလေးနဲ့ပတ်သက်ပြီးလဲဆို question လေးမေးစရာရှိတာညီမလေးမောင်လေးတို့မရှိရင်နောက်တစ်ခုသွားအောင်ပေါ့နော်နောက်တစ်ခုမှလဲဆိုဒီနောက်တစ်ခုပြီးရင်တော့ဒီဟာလေးပြီးအောင်လုပ်ပြန်လဲဆိုရမယ်ပေါ့နော်ဒါတဲ့ solution ရှိတဲ့ဟာလေးပေါ့နော်သူကပြောချင်တာဘယ်လို solution မရှိတဲ့ဟာမျိုးဆိုဘယ်လိုလုပ်မလဲပေါ့နော်အဲ့ဒါမျိုးဒီဟာလေးပြီးရင်လဲဆိုရကြတာပေါ့နော်ဒီနေ့တခြားဆိုတော့နည်းနည်းအရင်အများကြီးမသွားအောင်ပြက်ကိုတနိုင်တော့အတော်ပဲပေါ့နော်အရင်အများရင်လဲဆိုအုံနောက်ပြန်မခံဘူးပေါ့နော်မောင်လေးညီမလေးတို့ညံကောင်းနေမယ်အဲ့လက်ဆန်ညံမကောင်းဘူးပေါ့နော်လို့ဆိုတော့တနိုင်ရပို့လုပ်လို့မရပါဘူးဒါရင်ပို့လို့ရင်အဲ့လက်ကုန်းတော့တယ်မရောက်တော့ပါဘူးလို့ဒီဟာလေးနောက်ဆုံးတစ်ခုလုပ်အောင်နော်
I have here 3 linear equations of 4 unknowns, and like the first video where I talked about reduced row echelon form and solving systems of linear equations using augmented matrices, at least my gut feeling says, look, I have fewer equations than variables, so I probably won't be able to constrain this enough, or maybe I'll have an infinite number of solutions, but let's see if I'm right. So let's construct the augmented matrix for this system of equations. So my coefficients on the x1 terms are 1, 1, and 2. Coefficients on the x2 are 2, 2, and 4. 2, 2, and 4. Coefficients on the x3 are 1, 2, and 0. 1, 2, and 0. There's, of course, no x3 term, so we can use a 0 coefficient. Coefficients on the x4, 1, minus 1, and 6. 1, minus 1, and 6. And then on the right-hand side of the equal sign, I have 8, 12, and 4. 8, 12, and 4. There's my augmented matrix. Now let's put this guy into reduced row echelon form. So the first thing I want to do is I want to zero out these 2 rows right here. So what can we do? So I'm going to keep my first row the same for now. So it's 1, 2, 1, 1, 8. That line essentially represents my equal sign. And if let's see, what I can do is let me replace the second row with the second row minus the first row. So 1 minus 1 is 0, 2 minus 2 is 0, 2 minus 1 is 1, 1, negative 1 minus 1 is minus 2, and then 12 minus 8 is 4. There you go. That looks good so far. It looks like column x2, which is represented by column 2, looks like it might be a free variable, but we're not 100% sure yet. Let's do all of our rows. So to get rid of this guy right here, let's replace our third equation with our third equation minus 2 times our first equation. So we get 2 minus 2 times 1 is 0. 4 minus 2 times 2, well, that's 0. 0 minus 2 times 1, that's minus 2. 6 minus 2 times 1, well, that's 4, right? 6 minus 2. And then 4 minus 2 times 8, minus 2 times 8 is minus 16. 4 minus 16 is minus 12. Minus 12. Now what can we do? Well, let's see if we can get rid of this minus 2 term right there. So let me rewrite my augmented matrix. I'm going to keep row 2 the same this time. So I get a 0, 0, 1, minus 2, and essentially my equal sign, or the augmented part of the matrix. And now let's see what I can do. Well, actually, let me get rid of this 0 up here because I want to get in a reduced row echelon form. So any of my pivot entries, which are always going to have the coefficient 1 or the entry 1, it should be the only non-zero term in my row. So how do I get rid of this one here? Well, I can subtract I can replace row 1 with row 1 minus row 2. So 1 minus 0 is 1. 2 minus 0 is 2. 1 minus 1 is 0. 1 minus minus 2, that's 1 plus 2, which is 3. And then 8 minus 4 is 4. There you go. And now how can I get rid of this guy? Well, let me replace row 3 with row 3 plus 2 times row 1. With row 3 plus 2 times row 2, right? Because then you'd have minus 2 plus 2 times this, and they'd cancel out. So let's see, the zeros, 0 plus 2 times 0, that's 0. 0 plus 2 times 0, that's 0. Minus 2 plus 2 times 1 is 0. 4 plus 2 times minus 2, that's 4 minus 4, that's 0. And then I have minus 12 plus 2 times 4. That's minus 12 plus 8. That's minus 4. Minus 4. Now this is interesting right now. This is interesting. I've essentially put this in reduced row echelon form. I have 2 pivot entries. That's a pivot entry right there. That's a pivot entry right there. They're the only non-zero term in their respective columns. This is just a kind of a style issue, but this pivot entry is in a lower row than that one, so it's to the right. It's in a column to the right of this one right there. And when I just inspect it, this looks like this column 2 looks kind of like a free variable. There's no pivot entry there, no pivot entry there. But let's see. Let's map this back to our system of equations. These are just numbers to me, and I just kind of mechanically, almost like a computer, put this in reduced row echelon form. Actually, almost exactly like a computer. But let me put it back to my system of linear equations to see what our result is. So we get 1 times x1. Let me write it in yellow. So I get 1 times x1 plus 2 times x2 plus 0 times x3 plus 3 times x4 is equal to 4. Obviously, I could ignore this term right there. I didn't even have to write it. Then, actually, I'm not going to write that. Then I get 0 times x1 plus 0 times x2 plus 1 times x3. So I could just write that. Well, I'll just write the 1. 1 times x3 minus 2 times x4 is equal to 4. And then this last term, what do I get? I get 0 x1 plus 0 x2 plus 0 x3 plus 0 x4. Well, all of that's equal to 0, and I've got to write something on the left-hand side. So let me just write a 0, and that's got to be equal to minus 4. Well, this doesn't make any sense whatsoever. 0 equals minus 4. This is a nonsensical constraint. This is impossible. 0 can never equal minus 4. This is impossible. This is impossible, which means that it is essentially impossible to find an intersection of these 3 systems of equations, or a solution set that satisfies all of them. So when we looked at this initially at the beginning of the video, we said, oh, there's only 3 equations that have 4 unknowns. Maybe there's going to be an infinite set of solutions. But it turns out that these 3, I guess you can call them these 3 surfaces, don't intersect in R4, right? These are all 4-dimensional. We're dealing in R4 right here because we have, I guess each vector has 4 components, or we have 4 variables, I guess is the way you could think about it. And it's always hard to visualize things in R4, but if we were doing things in R3, we can imagine a situation where, let's say we had 2 planes in R3, so that's 1 plane right there, and then I had another completely parallel plane to that one. So I had another completely parallel plane to that first one. even though these would be two planes in R3. So let me give an example. So let's say that, this first plane was represented by the equation 3x plus 6y plus 9z is equal to 5. And the second plane was represented by the equation 3x plus 6y plus 9z is equal to 2. These two planes in R3, this is the case of R3, so this is R3 right here. These two planes, clearly they'll never intersect, because obviously this one has the same coefficients adding up to 5. This one has the same coefficients adding up to 2. And if we just looked at this initially, if it wasn't so obvious, we said, oh, we have only two equations with 3 unknowns. Maybe this has an infinite set of solutions. But it won't be the case, because you can actually just subtract this equation from the bottom equation from the top equation, and what do you get? You would get a very familiar. So if you just subtract the bottom equation from the top equation, you get 3x minus 3x, 6y minus 6y, 9z minus 9z. Actually, let me do it right here. So for that minus that, you get 0 is equal to 5 minus 2, which is 3, which is a very similar result that we got up there. So when you have two parallel planes, in this case in R3, or really any kind of two parallel equations or a set of parallel equations, they won't intersect, and you're going to get, when you either put in reduced row echelon form or you just do basic elimination or you solve the system, you're going to get a statement that 0 is equal to something, and that means that there are no solutions. No solutions. So the general takeaway, if you have 0 equals something, no solutions. If you have the same number of pivot variables, the same number of pivot entries as you do columns, so if you get the situations, let me write this down. This is good to know. If you have 0 is equal to anything, then that means no solution. If you're dealing in R3, you're probably dealing with parallel planes. In R2, you're dealing with parallel lines. If you have the situation where you have the same number of pivot entries as columns, so it's just 1, 1, 1, 1, and just and this is the case of R4 maybe right there. I think you get the idea. That equals A, B, C, D. Then you have a unique solution. Now, if you have any free variables, so free variables look like this. So let's say I have 1, 0, 1, 0, and then I have the entry 1, 1. Let me be careful. 0. Let me do it like this. 1, 0, 0, and then I have the entry 1, 2, and then I have a bunch of zeros over here. And then this has to equal 0. Remember, if this was a bunch of zeros equaling some variable, then I would have no solution, or equaling some constant. Let's say this is equal to 5, this is equal to 2. If this is our reduced row echelon form that we eventually get to, then we have a few free variables. This is a free, or I guess we could call this column a free column to some degree. This one would be 2 because it has no pivot entries, right? These are the pivot entries. So this is, let's say, variable x2, and that's variable x4. Then these will be free. We can set them equal to anything. So then here we have unlimited solutions, or no unique solutions. And that was actually the first example we saw. And these are really the 3 cases that you're going to see every time. And it's good to get familiar with them, so you're never going to get stumped up when you have something like 0 equals minus 4 or 0 equals 3. Or if you have just a bunch of zeros and a bunch of rows. But I want to make that very clear. Sometimes you see a bunch of zeros here on the left-hand side of kind of the augmented divide, and you might say, oh, maybe I have no unique solution. I have an infinite number of solutions. But you got to look at this entry right here. If this whole thing is 0 and you have free variables, then you have an infinite number of solutions. If you have a statement like 0 is equal to A, if this is equal to 7 right here, then all of a sudden you would have no solution to this, that you're dealing with parallel surfaces. Anyway, hopefully you found that helpful.
Okay, butတော်လေးမြစ်ရဲ့မြင်သွားတယ်ဗောနော်ဒီဟာလေးကြည့်ရတာလေနောက်ဆုံးဘက်မှာနောက်ဆုံးကဘာလေးကလည်းအသက်ပေါ့နောက်ဆုံးဟာလေးကအသက်ပေါ့အဲ့ဒါပြောကြအောင်နောက်ဆုံးအသက်ပေါ့နော်ဒီဟာလေးကလုံးဝသူ summarize လုပ်ပေးတဲ့သဘောလေးပေါ့နော် solution ရှိတာနဲ့ solution မရှိတာနဲ့ no solution ပုံစံမျိုးလေးနဲ့ပေါ့နော်ဟုတ်ပြီဒီနေ့ပတ်သက်ပြီးတော့ question လေးမေးစရာရှိလား let's go အဲ့လိုမရှိဘူးဆိုဒီမိနစ်ဒီမှာပဲရအောင်လေနော်အဲ့ section အသက်တစ်ခုထပ်ချပေးနေပေါ့နော်တခြားဟာနဲ့ပတ်သက်ပြီးတော့